Good afternoon. Welcome to this NPTEL course on Calculus for Economics, Commerce and Management. So this course is basically a calculus course. You will learn the basic concepts of calculus and there will be a slight focus on the aspects of economics and commerce. So how calculus will be applicable, how the concepts of calculus will be applicable to these economic fields. So that is what this course is about. Before we proceed, let us look at some of the logistics for this course. So this is an NPTEL course. It is Calculus for Economics, Commerce and Management. It is being offered by IIT Bombay and the course is conducted by Professor I.K. Rana. So this course is 8 weeks long and during the course of these 8 weeks you will learn different topics of calculus. Every week we will have weekly live problem solving sessions which will be held every Saturday from 3 p.m. to 5 p.m. So 2-hour long problem solving sessions we will have, and the aim of these problem solving sessions is to solve questions from the previous year's assignments. So as you must have seen in the course portal by now, that every week you will have a few MCQ questions to answer, and these MCQ questions are basically the assignment problems and they will be graded. So these assignment problems along with your final assessment will decide the grade that you get in this course, provided you opt for the final exam. Even if you don't opt for the final exam, it is a good practice to attempt the weekly assignments so that you are able to test your knowledge. These weekly live sessions will be held over Zoom, and all of you might have some doubts while you are watching the videos during the course of this lecture series, and you can clear your doubts through 3 channels. First is this live problem solving session that we will have. Second is the course forum. So if you go to the course website on NPTEL, on the top you will see one Q&A button. If you click on that Q&A button, it will lead you to an external link, which is a Google forum link. It's a Google group actually. So that's the course forum. Over there you can ask any doubt that you have, any of the questions that you have, and the course TAs as well as the instructor and even I will look at those questions, and all of us will try to answer as many questions as possible. And the third channel for asking your doubts is on the YouTube channel for this course, for these live problem solving sessions, and that will be my personal YouTube channel. The handle is @Prasad Radhika because my name is Radhika Prasad, and that's the link for the YouTube channel. I will put it up in the Zoom chat box as well, so you can bookmark it, you can subscribe to it so that you stay up to date with the course related information. Okay, so for those of you who joined late, and if I did not introduce myself to you, I am Radhika Prasad and I am a PhD student at IIT Kanpur, and currently I am working in the field of quantum optics in the Department of Physics. So that's all about myself and about the logistics for this course. If you have any queries regarding this, please put it up in the chat box. Okay, seems like everyone is clear with this. So if at any point of time, if you have any question, you can put it up in the Zoom chat box or in the YouTube chat box. Okay, so one more thing. All these live problem solving sessions, even though they are conducted over Zoom, they will also be live streamed on this particular YouTube channel. So if you face any issues with Zoom regarding the audio quality or the video quality, then you can head over to the YouTube channel and watch the live stream over there. Typically, I've seen that the quality on YouTube is slightly better than the quality on Zoom. And if by any chance you happen to miss the problem solving session for any particular week, then again you can go to the YouTube channel and watch the replay of the video. So I guess we can now start with problem solving. So you might have seen that there is a week 0 as well, and there were some questions in week 0. So week 0 is not graded, it is just for practice, just to get you into the problem solving mode and just to give an idea of the kind of questions that you can expect going forward. So that was what week 0 is about. So let us start with some questions which are based on week 0. So the first question is over here. You are given the following 3 sets: set A, set B and set C, and the elements of the sets are enumerated as given. The question is A equals B equals C, and options are yes or no. So I will start a poll in the Zoom. You will see a poll on your screen and you can select the correct option. Please do not put the answers in the Zoom chat box. That might influence other people's answers. You select your answer in the Zoom poll itself. Take about a few minutes to answer this question. The poll is live now. Okay, so now that you have attempted the poll, let me now discuss the answer with you. So the correct option is option, let me select my pen. It's option A, yes. And why is that? Because you are supposed to look at the distinct elements. If the elements are repeated, that doesn't matter. A set, basically in a set we look at the distinct elements. So if you look at distinct elements, it is A, B, C. So you have A, B, and then A is repeated but C. Then you have A and C over here, then C is repeated, then B is repeated again, A is repeated again. So if you look at distinct elements, then the distinct elements are A, B and C, and these are same for the sets A, B and C. So that's why the correct option is yes. So those of you who got the correct answer, very good. Those of you who did not, I hope you are able to understand now what the logic behind this answer is. Okay, so let us now proceed to the next question. I will read out the question first for all of you. Have a look at the following graph. The point Q lies on the red curve as well as the green line OQ and the blue line PQ. Which of the two lines OQ and PQ is a secant and which is a tangent to the red curve? These are the four options. Let me read out the options as well. OQ is a secant and PQ is a tangent. Option B, neither OQ nor PQ is a secant. Option C, both OQ and PQ are secants. And option D, both OQ and PQ are tangents. So again, let me refresh the poll and all of you please try to answer the poll. So I request all of you to attempt the poll. It is a good idea to at least try the question before we discuss it in the class. You all should at least try. Even if you are not able to understand, try to read the question over and over again. Try to look at the options. Try to think and see if you are able to come up with some idea for the solution. So again, I have restarted the poll. It will appear on your screen. Please select the correct option over there. I see that some students have still not attempted the poll. All of you, please attempt the poll. Once all of you attempt the poll, only then I will proceed to discuss the solution. Okay, so let us now discuss the answer. So the correct option is option A once again. OQ is a secant and PQ is a tangent. So let us look at this graph. We are looking at this point Q, which is on this red curve. This is the red curve. I'm just retracing it for you like this, and this is the green line over here. And that's the blue line. Yeah, better. And once again, let me highlight this point Q. Now, why I am calling OQ as a secant and PQ as a tangent? So, tangent touches the curve only at one point. Whereas a secant can touch at more than one point. So you can see that this line OQ, the green line, touches the red curve at two locations, at the point O as well as at the point Q. Whereas the blue line PQ touches the red curve only at one point, which is Q. That's why OQ is a secant and PQ is a tangent. So if you have any questions, please put it up in the chat box. Okay, someone is asking a question in the chat box. Someone is saying that what if the green line was something like this? In this case also it is touching the curve only at one point. Would that then be a tangent? And the answer is no. Why? Because tangent is characterized by a derivative, and you will learn this later in the course. It's defined as this dy over dx, which basically means the rate of change of the curve, and the instantaneous rate of change means how much change in y you are seeing for a given change in x. So an approximation would be delta y over delta x. So for a delta x change in the x-axis, how much the curve is changing along the y-axis, the ratio of that, the instantaneous ratio, gives us the slope of the tangent curve. So that is the definition, that is the more precise definition of a tangent. And if you look at this curve, let me change my color. If you look at this curve, let's say around this point Q, if you want, so around this point Q, let me see. So if I am taking this much change in x, then this much change in y is there. So if you do delta y over delta x, the slope, I'm sorry, maybe I should choose a different color. Maybe I'll try purple. So okay, this is also, so this much change in y, and then the corresponding change, sorry, this much is delta x and the corresponding is delta y. And if you, oh sorry, the page size is changing. If you do this delta y over delta x, then you get this slope. And in the limit, if you reduce delta x and delta y to infinitesimally small values, so that you are just exactly at the point Q and not very close or in the neighborhood of point Q, then you will see that this slope actually matches with the blue one. Already, even in this approximate case, you can see that the slope is very much close to this blue curve. So blue curve is indeed the tangent. So that is how you find a tangent. So you want to find a tangent around a point, you actually find the limit of delta y over delta x, that gives you the slope of the tangent line. So I hope it is clear how to find the slope of the tangent and what is a tangent curve. Okay, so no more questions it seems, so we can proceed further. So next question is on limit. Again, limit I introduced over here in the previous. So here also we will take the limit. Taking the limit means from here to here, it's actually based on taking limit or basically infinitesimally small change or infinitesimally small neighborhood around the point Q. Similarly, here also this question is on limits. The question is, consider x to be a quantity whose value can be calculated. What is the value of the quantity 1 plus x over 1 minus x squared as x approaches 0? Once again, I have started the poll. Please take some time to answer. Okay, so let us discuss the answer now. The correct option is option D. This is a very simple question of limit actually. You don't have to use any properties or any identities for evaluating this limit. Simply plugging in the value will give us the result. So this is clearly 1, because when you plug in the value of 0, you get 1 plus 0 over 1 minus 0 whole squared, which is 1 over 1 squared, which is just 1. So this is a very simple question of limit, wherein you just plugging in the value of x gives us the answer. Notice that if this limit was x tending to 1, then the denominator will become 0. This will become 0 and the whole thing will then blow up to infinity. So this is basically undefined. It will just blow up to infinity. So you need to take care as to what limit we are taking. Okay, so we can proceed further. the fourth question for the day. If a car travels from point A to point B in 50 minutes, where the distance between A and B is 18 kilometers, what is the speed with which the car travels? Assume that the car travels with the same speed all the time. The options are option A 20 meters per second, option B 10 meters per second, option C 15 meters per second, or option D 5 meters per second. Once again, the poll is live on your screens. All of you, please attempt the poll. Okay, so this was a very simple high school level question, and all of you got it right, as it should be. The option is 20 meters per second. Pretty simple, because we know that speed is equal to distance over time, and distance is given to us 18 kilometers. Time is given to us as 15 minutes. We just have to do now the conversion into meters per second. So 1 kilometer is 1000 meters, and 1 minute is 60 seconds. So let's see. So that's cancelling out everything, gives us 20 meters per second. Pretty easy and simple, basic high school level question. If in case you have forgotten, then speed is distance over time. That's the formula that we have used. Okay, so no questions up until now, which is great. Let us move to the next question. This one is a little bit trickier. you have to pay attention to the notation over here. So let E be equal to the intersection of sets of the form minus n to n. Sorry, this question is a little bit incomplete. I forgot to write for f. Yeah, now it is complete. So E is the intersection sets from minus n to n with parenthesis, that is open brackets, and F is intersection of the sets minus n to n with square brackets or closed. Then which of the following statements is true? And options are A, both E and F are empty, B, E is empty, F is non-empty, C, E is non-empty and F is empty, or D, both E and F are non-empty sets. So you have to pay attention to the notation used over here, otherwise it might be a little bit tricky. So pay close attention to the kind of brackets used over here, the kind of intersection, and the set, which is set over natural numbers. So just keep these things in mind and then attempt the question and finally answer the poll. Okay, so let us now discuss. Before that, let me just clarify the notation. So this capital N is the set of natural numbers. Natural numbers meaning 1, 2, 3 and so on and so forth. 0 is not included. Negative numbers are not included. Now this set E is actually n belonging to natural numbers and intersection of the form minus n to n. So that means it is the following. So for n equals 1, minus 1 to 1, intersection minus 2 to 2, intersection minus 3 to 3, and so on and so forth. Now you can clearly see that minus 1 to 1 will belong to minus 2 to 2, meaning minus 1 to 1 is a subset of and not equal. It's a strict subset of -2 to 2, which is a strict subset of -3 to 3, and so on and so forth. That means -1 to 1, that range is entirely contained within -2 to 2, and you can clearly see this on the number line. So this gives me that my E is essentially this particular set, because you are taking intersection of a subset with a set, then that will just be the same as the subset. Okay, meaning if A is subset of B and I want to find, this means that A intersection B will actually be equal to A. This is what I am trying to say. Now this is actually equal to the null set, because the parentheses, these parentheses are actually open brackets, meaning the endpoints are not included. So these parentheses over here are open brackets. Open brackets means endpoints not included. Okay, so +1 is not included, -1 is also not included, and 0 is not a natural number, so that gives us the null set. Similarly, F will then be, by the same logic of subsets and intersection of subset and set, this will be -1 to 1, and now these square brackets are actually closed. Closed meaning endpoints are included. So endpoints are included, that means +1 is included. So this is the set containing the element +1, because -1 is not a natural number, 0 is also not a natural number. That means F is not empty and E is empty. So the correct option is option B. E is empty, F is non-empty. Okay, any questions up until this point? Okay, so someone is confused about the parenthesis and the square brackets. So this parenthesis or round brackets means that the range is open, meaning endpoints are not included. So minus n and plus n both are not included in this range, whereas square brackets imply that both the endpoints are included. And if you have something like a range, if you have, let's say, something like this, then it means that plus n is included but minus n is not included. You can also have something like this. This would mean that minus n is included but plus n is not included. So you can consider these also as some options and then try answering this question. Let's say you can keep E as this top example and F as this bottom example, and then try to see what happens to the sets. So I hope these round brackets and square brackets are now clear. So these round brackets are also known as parentheses. Okay, so 5 questions are complete. We have actually 10 questions with us for today. So we are halfway through in this lecture, and this is supposed to be 2-hour long session. We are roughly midway, and let us take a break of 5 minutes so that you also can grab a glass of water or something and get rejuvenated for the second half of this lecture. So take about a break of 5 minutes and then we will return. Okay, so I hope everyone is back from the short 5-minute break, and we can proceed to the next half of this session, the next 5 questions. So question number 6, consider the function f going from real numbers to real numbers with fx equals sin x. Which of the following statements is true? F is neither injective nor surjective. F is injective but not surjective. F is surjective but not injective. Or option D, F is both injective and surjective. So yeah, these words, if they are new to you, we will discuss. If not, then if you know the definitions of the word injective and surjective, you have to figure out whether the given function fx equals sin x is injective or surjective. So again, as always, please take about a few minutes to answer in the poll. Okay, so let us now discuss the answer. The correct option is option A. F is neither injective nor surjective. So it seems that most of you are not aware of these terms. Again, these are basically high school concepts or maybe class 12th concept, if I'm not wrong. So, but we will revise these terms once again. So if you have a function which goes from A, which is defined from A to B, then what we have is f is the function, A is the domain, and B is called the codomain. Or also called the range. Actually, range can be a subset of codomain. So a function is defined from a domain set to a codomain set. And the definition for surjective is also known as an onto function. And what this means is that for every element in codomain, there is at least one element in the domain that maps to it. That means if you have an element in codomain, then there will be some element of the domain which maps into that element. by the function. That means you cannot have elements in codomain which do not have any mapping from the domain set. So each of the elements in your codomain set should have some corresponding element in the domain set, which basically the function maps from. So that's a surjective set, onto set, surjective function or an onto function, injection or an injective function, so injection is also known as a 1-1 function. And the definition for this is distinct elements of domain get mapped to distinct elements of codomain. Now, this capital R is the set of real numbers. And let me draw the sin x function for you. Now let me try to draw as good a sine function as I possibly can. Yeah, looks great, I think. Let me copy paste it again. Okay, so labeling the axes, this is x, this is y-axis, which is sin x, and this function goes from +1 to -1. Now you can clearly see that this is not a surjection, because let's say you have this particular value over here. Let's say this is what it will be, something like 1.2 maybe. So 1.2, actually there is no element in the domain, which is x over here. This is domain and this is over here codomain. So this element in codomain 1.2 has no element in the domain which actually maps into it. So clearly this is not a surjection, and clearly you can see that for the element 1, you have this element which maps into it, and you also have, if you extend it further, you also see that you have this particular x which also maps into it. And if you want to know, then this is actually pi by 2, and this is 2 pi plus pi by 2, which is 5 pi by 2. So both these elements in the domain actually map into the same element in the codomain. So distinct elements, so pi by 2 and 5 pi by 2 are distinct elements of the domain, but they get mapped into the same element of the codomain. So that means this is not an injection. So fx equals sin x is neither surjective nor injective. So are there any questions? For some of you, these terms are probably new, surjection and injection. Okay, someone is asking what is an example of a function which is both injective and surjective. So an example would be, so f going from R to R such that fx equals x, this function is, you can clearly check, both injective and surjective. So that's an example of both injective and surjective. Similarly, you can think and construct examples where in which f is, let's say, injective but not surjective, or when f is, let's say, surjective but not injective. You can think and construct examples. Okay, so moving forward, yeah, we have another question on injective and surjective, and now that the definition has been explained, I hope you will be able to solve this question on your own. Consider the function f goes from same set of real numbers to real numbers, but this time fx equals 2x plus 5. Which of the following statements is true? Option A, f is neither injective nor surjective. Option B, f is injective but not surjective. Option C, f is surjective but not injective. And option D, f is both injective and surjective. Okay, so take a few minutes to answer in the poll. Okay, so the correct option is option D. F is both injective and surjective. This is similar to this example that I gave, fx equals x. Again, it's a linear function. 2x plus 5 is also a linear function. A linear function from real numbers to real numbers will always be both injective and surjective. But let me draw the graph for you. So that's the curve. And clearly you can see it is both injective and surjective. So we are slowly nearing the end of today's question set. This is question number 8. The sum 1 squared plus 2 squared plus so on and so forth up until n squared is equal to what? Option A is n into n plus 1 by 2. Option B is n squared into n plus 1 squared by 4. Option C, n into n plus 1 into 2n plus 1 over 6. Or option D, n into n plus 1 into n plus 2 over 3. So take a few minutes to select. The correct option is option C. Oh, sorry, I need to change the color of my pen. And this can actually be done by the method of proof by induction. So in this we assign this Pn expression to be the following. Now first we will look at P1. This is 1 squared, which is equal to 1, and this is clearly equal to 1 into 1 plus 1 into 2 plus 1 over 6. So for n equals 1, this statement is indeed true. Now we will assume that it is true for Pk, like n equals k. Now we need to show that Pk plus 1 is also true. So Pk plus 1 Now we will take k plus 1 common. Now let us look at this term in square brackets. Now if we look at it, then this is basically k plus 1, then k plus 1 plus an extra 1, and 2 times k plus 1 plus 1. So this implies that Pk plus 1 is true. Sorry, this divided by 6, and therefore Pn is true. Just to repeat, so in proof by induction, we assume that a particular statement is true, and then we show that it is indeed true. So first we have assumed that it is true, then we have we actually show why it is true. Why it is true? Because it is true for n equals 1, and if it is true for n equals k, and if we show that then it is also true for n equals k plus 1, then that means it will be true for all n. Because if k takes any value, and if k plus 1 is also satisfying, then no matter what value of k you take, k plus 1 will also satisfy. As a result, it will satisfy for all values of k, and meaning for all values of n. So that's the crux of proof by induction. Now we can proceed to the next question. This is the second last question. Consider the function f going from z plus to z defined by f1 equals 3, f2 equals 5, fn equals 3 times fn minus 1 minus 2 times fn minus 2 for all n greater than equal to 3. Then fn is equal to, we need to select the form of the function fn. Option A, 2n plus 1. Option B, 2 to the power n plus 1. Option C, 2 to the power n minus 1 plus n plus 1. Or option D, 7n minus n squared over 2. So please take about a minute or two to answer in the poll. Okay, so let us now discuss the solution for this. Now in this, because it's an MCQ question, actually we can just eliminate out the wrong options. For that, let us first find out what f3 is. First of all, this z means the set of integers. So z is the set of integers, and so let's find f of 3 by this expression over here. It is 3 times f of 3 minus 1, which is 2, minus 2 times f of 3 minus 2, which is 1, f of 1. So 3 times f2 is 15, so 3 times 5 is 15, minus 2 times f1 is 3, so 2 times 3 is 6, so 15 minus 6, this is equal to 9. Now let us look at option A, 2n plus 1. So when n is equal to 1, so 2 times 1 is 2 plus 1 3, which satisfies this f equals to 1. But when n is equal to 2, so let us actually look at all these options. So when n is equal to 2, 2 times 2, 2 into 2, that is 4 plus 1 5, which is also true. Now when n is equal to 3, then 3 times 2 is 6 plus 1 7, which is not equal to the 9 that we just found out. So this is not the correct option because it does not satisfy for f3. Then let's look at option C. Again, when n is equal to 1, so 2 to the power 1 minus 1, that's 2 to the power 0, which is 1. 1 plus 1 plus 1, that's 3, it satisfies. Then f2, 2 to the power 2 minus 1, so that is 2, plus 2 4 plus 1 5, it satisfies. Then n equals 3, so 2 to the power 3 minus 1, which is 2 to the power 2, which is 4, plus 3 7, plus 1 8, so it does not satisfy because this was giving this over here 7, this is giving over here 8. Now let us look at option D. So for n equals 1, 7 minus 1, which is 6 by 2 3, it satisfies. For n equals 2, 7 into 2 14, minus 2 squared 4, so 14 minus 4 is 10, 10 by 2 is 5, it satisfies. Then n equals 3, 7 into 3 is 21, 21, and 3 squared is 9, so 21 minus 9, that is 12, 12 divided by 2 is 6, so this also does not satisfy because it gives 6. And this 2 to the power n plus 1 then is the correct option. And you can see it is satisfies for n equals 1, 2 and 3 and also for all the other n. And you can also see this thing. So let us look at the expression. And if we use this expression 2 to the power n plus 1, so then we have 3 if we look at the right hand side, so this is same as LHS, it's basically consistent. So that means everything is consistent and it is true for these 3 special values also that we saw. So the correct option is obviously option B. So are there any questions on this? Okay, if not, then we proceed to the last question for today. It is a true false type question. State whether true or false. For every x belonging to R, there exists n belonging to n such that x is less than equal to n. True or false? So let me start the true false type poll. This is the last poll for today. So all of you please try to answer. Okay, so now the answer. The answer is option A, which is true. So once again, to remind, R is set of real numbers and n is set of natural numbers. So, and both these are infinite sets. Real numbers is uncountably infinite. While natural numbers are countably infinite. So, what countably infinite means? It goes like 1, 2, 3, so on and so forth. Whereas real numbers, even between 1 and 2 you have 1.1, even between that you will have 1.01 and so on and so forth. You can't really count them. So that's why it's uncountably infinite. So what this basically means, that there is an integer which is greater than a real number. So for every real number there exists an integer which is larger than the given real number. Same will be true other way around also. There will always be a real number which will be larger than a given integer. So, okay, this brings us to the end of this question answer problem solving session for today. And once again, to remind all of you about the course logistics. So this is a course calculus for economics, commerce and management. It is 8 weeks long, and every Saturday from 3 p.m. to 5 p.m. we will have these live problem solving sessions over Zoom, which will also be live streamed on this YouTube channel over here. So please do attend these sessions, and if you happen to miss, you can always go back to the YouTube channel and watch it again. Sorry about that. Okay, so this brings us to the end for today. Thank you very much for attending, and we will meet once again in the next week on next Saturday. So this week, actually, even though this is week 1, we actually tried solving some week 0 problems, which are basically some preliminary problems before the actual course content starts. So we just solved like a few preliminary questions, very simple questions, basically class 12 level at best, and that is what we have done today. And from next week, we will actually look at week 1 content and the questions pertaining to them. Okay, thank you very much. Bye.